So continuing on with these notes on solving systems of equations by elimination, this one right here, no opposites. I can make this 5 into a negative 10, right? Opposite of 10 will be a negative 10, so I just gotta think of what I need to multiply this by to make it a negative 10, which is negative 2. So if I multiply 5 by negative 2, I'll get negative 10y, which will cancel out with that positive 10y in the top equation. Don't forget to multiply everything in the equation now by negative 2, so negative 2 times 3, negative 6x, negative 2 times negative 3 is 6. I'm just going to rewrite the top equations so they're stacked right on top of each other. There's that. Now I can combine these equations and the y's will cancel. They'll zero out, that is. Negative 6 plus negative 7 is negative 13. 6 plus 7 is 13. So now we'll divide. Remember, the y's canceled or zeroed out. And now 13 divided by negative 13, negative 1. Take that y equals negative 1, plug it into one of these original equations. Let's use the top one, negative 7x plus 10y, so plus 10 times negative 1 equals 7. Negative 7x plus 10 times negative 1 is negative 10. Add 10 to both sides. And wait a second, guys, I just realized that this is x. Right here when I added these, it should have got negative 13x. This should be an x, which means that x equals negative 1, not y. And then all this I would need to fix because I accidentally plugged in for y instead of x. So let me fix that. So negative 7 times negative 1 plus 10y equals 7. And I can now carry on with this. So 7 plus 10y equals 7. If I subtract here, I'll actually get 10y equals 0. And then if I divide 0 divided by 10, 0 divided by anything, right, is 0. So my answer is x is negative 1, y is 0. Let me go ahead and write that. X comma y. And I would, like, as usual, I mean, you don't have to use mental math here. You could just write it out. But mental math is just, it could save you a few seconds. So plug in negative 1 for x, 0 for y. Negative 3 times negative 1 is negative 3. 5 times 0 is 0. Negative 3 plus 0 is negative 3, so it checks out to be correct. And now this is actually a new idea. The new idea being there's no way I can multiply just one equation because 3 times, no matter what I multiply 3 by, I can never make it into the opposite of 4. Same thing with the 2. No matter what I multiply 2 by, I'll never be able to make it into the opposite of 3. So I do need to multiply both equations on these problems. So I have some choices here, guys. I can choose to make opposites out of the x's, right? I can make 12 and negative 12, which would mean I multiply by 4 here and by negative 3 here. The other option is I can make 6 and negative 6 out of the 2 and the 3. I can multiply by 3 here and by negative 2 here, and that's what I'm going to do because those numbers are just a little less. So multiply by 3 here to make 6y. Multiply by negative 2 here to make negative 6y. I will have made opposites out of the y's, and that's one way to solve this one by elimination. So multiply the top equation by 3. 3 times 3x, 3 times 2y, 3 times 1. Bottom equation by negative 2. Again, remember we're making opposites out of the y's, so we have to think of what to multiply by, which was 3 and negative 2. Negative 2 times 4x, negative 2 times 3y, negative 2 times negative 2. Now I can add these equations and the y's will zero out. 9x minus 8x is x, or if you prefer 9x plus negative 8x, it's still x. 6y minus 6y is 0, or 6y plus negative 6y if you prefer, still 0. 3 plus 4 is 7. I now know what x is. I can plug that into one of the original equations. Take the top one, 3x plus 2y equals 1. So 3 times 7 plus 2y equals 1. 21 plus 2y equals 1. Subtract 21. 2y equals negative 20. Divide by 2. Y equals negative 10. So here my answer is x, comma y. Check it here. 4x plus 3y equals negative 2. 4 times 7 is 28. 3 times negative 10 is negative 30. 28 plus negative 30 is negative 2. So once again, just kind of checking my answer. This next one, I can make opposites. I still have to multiply both equations, and remember, I'm always trying to think of the LCM of the coefficients. The least common multiple of negative 5 and 4 is 20. So I can make this into negative 20 and this into 20. Multiply by 4 and by 5. The other option is I can make these into 10 and negative 10. I can multiply by 5 and negative 2. So either way would work. I think I'm going to do or make the x's into opposites here. I'm going to multiply the top by 4 and the bottom by negative 5. Again, I could have multiplied the top by 5 and the bottom by negative 2. That would have also worked. It would have made the y's opposite. So in doing this, let's see, 4 times negative 5, 4 times 2, 4 times 1, and then negative 5 times 4, negative 5 times 5, and negative 5 times 14 is 70. So now that I've done this, let's see here. Oh, I messed up, you guys. 4 times negative 5. This should have been a positive 5 because I need a negative 20 and a positive 20. So 5 times 4 would be a plus 20x. 5 times 5 would be a plus 25y. And 5 times negative 14 would be a negative 70. So, you know, if you make a mistake, obviously you can fix it. But definitely multiplying to get a negative 20 and a positive 20. Remember, I need opposites. So 4 times negative 5 and 5 times 4. So anyhow, now that I have opposites, these x's will zero out. 8 plus 25y is 33. And negative 70 plus 4, or 4 plus negative 70, either way. 4 minus 70, that's negative 66. Now I can divide to wrap this up. Negative 66 divided by 33 is negative 2. Now that I know that y is negative 2, I can plug it into one of the original equations. I'm going to plug it into the top. So negative 5x plus negative 4 equals 1. I'm going to go ahead and add 4 here on both sides to get negative 5x equals, whoops, it should have been a plus 4. 1 plus 4 is 5. Now divide and done. Well, just about done. So 5 divided by negative 5, x is negative 1. Write your answer, x, comma, y. And just mental math, check it, right? 4x plus 5y equals 14. 4 times negative 1. 5 times 2 is 10. So let's see here. Oh wait, my bad. Y is -2. Almost messed that one up. So 4 times -1, 5 times -2. So -4 plus -10. It is -14. So again, I can move forward with confidence on that. And so I'm going to go ahead and get into special cases, right? Special cases you've seen before, where if the lines solving a system of equations, if you're graphing and the two lines intersect in one place, you have one solution, right? One solution. If two lines get graphed and they're the exact same line, you have infinitely many solutions. And then if two lines get graphed and they're parallel, right, they'll never touch. There's no solution. So that's graphing. But here it explains what you'll get in these problems. So in these problems, if you get a value for the variable, you get a number, and you have one solution. If the variables go away but the statement is true, you get infinitely many solutions. That should make sense. If it's a true statement, it's infinitely many solutions. If the variables go away and it's false, then no solution. So false associated with no solution is fairly logical. So let's see what we get here. Let's make opposites here. Let's assume we're solving by elimination. We'll make opposites. We'll multiply the bottom by -2 to make opposites out of the x's. Alright, we'll multiply everything by -2. We'll get -2x minus 6y equals -18, which you can already see the top. I'm going to rewrite the top equation, 2x plus 6y equals 18. Everything came out to be opposites, you guys. So now when I combine the equations, I get 0 and 0 again, so that's just 0. And -18 plus 18 is also 0. So when I end up with 0 equals 0, I have to know that the answer is actually infinitely many solutions, as it shows me here. If all the variables zero out, and I end up with a statement that's true, like 0 equals 0, then I do have to remember a true statement will result in infinitely many solutions, or an infinite number of solutions. Now this one here, let's see, I already changed the signs. It looked like I already got started on this one. So I changed the signs to make opposites, right? The opposite of -2 is +2. And the only way I can make opposites out of this is if I make opposites out of everything in this equation. So make the 5y into a -5y and the 12 into a -12. And now when I combine these equations, -2 plus 2 is 0. 5 plus -5 is also 0. So all the variables zero out. But 7 plus -12 is 0, that's -5. So from here, right, 0 equals -5 is false, right? And from here, right, the variables are all gone and the statement is false. I have to know that I have no solution. So that was just a couple solving by elimination that end with like a special case, right? And that is all.